So we're going to start this lesson by talking about some basics of the Python type system, and then we'll introduce the concept of a metaclass shortly. To start out, let's make a bunch of Python objects, like x is 42, y is equal to hello, z is equal to 3.5, and so forth. Every single thing that you create in Python has a type associated with it. Like the type of x is int, and the type of y is stir, and the type of z is a float. So everything that you make has a type. Under the covers, by the way, that type is held in an attribute class. So every object that you create has an associated class that it's attached to. This idea of types extends to the classes that you create yourself. For instance, if I make a class point, let's give it an init method that sets up some data. If I do that, maybe I'll give it a method as well, just to have it do something interesting here. Okay, so we have a class where you have a point and then you can move it. That class, like if I make a point object, point23, it also has a type, and the type is essentially that class. Every object that you make has this type associated with it. The name of the type is usually how you create instances. When I made a point, I used the name of the class point to do that. That also applies to Python's built-ins. Like if I say a is equal to int, that makes an int. Or if I say b is equal to float, that makes a float. So everything that you do with classes kind of mirrors what happens with Python's built-in objects as well. Now, one of the things that gets kind of interesting about this is that the classes that you work with are also objects kind of in their own right. Like if I look at point, it will come up and say, well, I'm a class. Or if I look at int, it says that it's a class. Float is a class. Stir is a class. All of these classes follow the same kind of convention that you have with like an integer. Like if you have the x is 42 and I ask like what the type of x is, I could ask that same question about what is the type of point. And it will come back saying, well, that's a type. If I ask what the type of int is, that's a type. If I ask what the type of float is, it's a type. What's happening here is Python is telling me that all of these things are types. Point is a type, int is a type, float is a type, stir is a type. Another way to say that is that all of these things are actually instances of types. And the reason that I'm using that terminology is it turns out that type is actually a class in Python. If you look at what type is, it says that it's a class. And you could ask, like, what do you mean that's a class? Like what is going on there? Type is the class that creates other classes. It basically creates instances of types. And the reason that I mention this is I want to talk a little bit about what a class definition actually does in Python. So let's go up and look at this point class for a second that I just did and think about deconstructing what that class is. One of the things that a class has is it has a name, point. So let me make a name here. I'm going to make a name point. Another thing that a class has is it has a set of base classes. This is inheritance, essentially. So in this class, the base is object, but it could be something else. You have some base classes. I'm going to make a tuple here. This is a one tuple. That syntax is a little confusing there. And then the other thing that a class has is it has all of the methods that you define. Okay, it has an init method, it has a move method. It might have other methods there. So what I'm going to do for that is I'll just write some Python functions out. Okay, so these are not in a class right now. I'm just making some Python functions, just kind of all on their own here. The reason for doing this will become clear in a second, so let's make those functions. What I'm going to do with those is I'm going to make a little dictionary that holds those. I'm going to say there's an init method, which is that init function, and then there's a move method, which is the move method. What I've got set up right now is I have three different pieces. I have the name of the class, I have the base classes, I have this dictionary that has some functions that I've defined in it. And so here's how the type class works. I mentioned that type is this class, and it makes instances of types. What actually happens is when you define a class in Python, it calls this type class, and it feeds this information, and it says, okay, here's the name of the class, here are the bases, and here are the methods. So you say point, like is equal to that, and what you will end up with is a class object, and you can start using that to make instances. It might look kind of wild, but that is what is happening when you define a class definition, is Python takes that information that's in the class, and then it feeds it to type to actually make a type object. That's some things that are happening underneath the covers. Now, why would you actually care about this? Where is this going? Well, it turns out that this type class is actually something that you can customize. You can change it, you can modify it. And you can say, well, how do you do that? The way that you can modify a class is through inheritance. Like I can make a class myType that inherits from type, and then I could change the way that it works. What I'm going to do here is I'm going to define a new method where you give me the class name, the bases, and maybe the methods here. I'm just going to put some print statements here, sort of saying that you're creating a class. There's the name. And I'll print out the bases here. I'll just print out the list of the method names there. And then what I'm going to do is use the super function to pass this along. Okay, so I'm customizing type. If I do that, I could use that class to make a type as well. Like I could say point is equal to myType, where I give it the name and the bases and the methods. And that would also create something that works like a class. Like if I were to look at point, it would say, well, there's a class point. And you can use it, works exactly the same way as the other one did. But one of the things you'll notice is that it had this extra code that I put in there. This thing that I've defined here, this is an example of something known as a metaclass, essentially a class that creates class definitions. This myType is actually making classes as a result. It turns out that this is kind of an interesting way to monitor or supervise what happens in class definitions. So you've got this myType thing that I've defined, essentially an alternate way of making a class. And what Python provides is a way of using that in a normal class definition. For instance, I can come in here and I can say class point. What I can do is specify that I want this class to be created using myType instead of the normal machinery. I can come in here and say, well, I want point to use that metaclass. And then I can put the usual methods in there. Like that. Okay, so we have our move method and our init method and so forth. And what's going to happen here is you're going to see this class that I defined get processed through that code that I wrote above. It comes up and says, oh, you're making point. And here's some methods that got defined on that. Essentially, I've intercepted a step of class creation by doing that. It even gets a little bit more interesting than that. Turns out if I start using inheritance, like let's say I make a class new point that inherits from point, and then I start adding new methods to this, I don't know, put a yow method in there, you're going to see the same metaclass code that I wrote stick to that. You see it come up saying, oh, you're creating new point, and it has methods from that. If I start inheriting from new point, I don't know, my point inherits from new point, what we're doing is using more inheritance, you will continue to see that code fire. So here's kind of the big idea on this. If you're writing, say, like a big application, maybe a framework or a library or something, this mechanism of defining a metaclass can be used to start supervising what happens in a whole hierarchy of objects. For instance, I could make a little base class that specifies some kind of new metaclass, like myType. We'll just put nothing in there. And then what could happen is that base could serve as like the top of like a whole hierarchy of objects. If I start defining classes that inherit from that base, you're going to see me sort of monitoring everything that happens under that. And so this becomes a tool for performing kind of management tasks, supervision kinds of tasks, and other things related to class definition. So this is some of the basic machinery. In the next two parts, we're going to look at two practical examples of why you might care about something like this.